Okay, hello everyone, it's Mr. Claudy. Today we're going to be doing a lesson on combinations. Actually, the next three lessons are setting us up for the binomial distribution, but I call them the binomial distribution backstory, because before we can really understand the math of this distribution, we have to go back to some counting concepts and some sequence and series concepts, if you can believe that. So let's start today with this the first story of our this first part of our backstory. Today's lesson really looks at combinatorics, which is a branch of math you might study in university. There's a whole department of combinatorics at most math faculties. The things that we look at high school are called permutations and combinations. A permutation, an example of one would be, how many different ways can three students place in a 100-meter run? We have A, B, and C. So we could have A is first, B is second, C is third. We could have A is first, C is second, B is third. Okay, now what if A is not first, but we have B is first? Or we could have C first, I guess. Cap. And I don't think there's any other ways we can do it. So there are 6 permutations. And a little note here, order matters. Right, these all have the same letters, but they're in different orders. But they all count as part of the 6 possibilities. Now, you can imagine, like, what if I had to do this with 10 students instead of 3? You can imagine how many different versions I have to write out. A, B, C, D, E, F, G, H, I, J. Then A, B, C, D, E, F, G, H, J, I. And then you have to change everything around. It would take forever. We have a little bit of a shortcut that can help us in that, imagine you're making your podium. You have your first place, second place, and third place. When you're finding out your ordering, well, there's 3 possibilities for the first place or person. Once you've taken out the first place and you're looking at the second, well, you've already chosen the first one, so there's only 2 possibilities left. And then there's only 1 possibility by the end. So the shortcut is to say 3 times 2 times 1. That's how permutations work. You can multiply the possibilities together, but each time you have 1 less possibility. So if you had 10 students, you would have 10 times 9 times 8 times 7 times 6 times 4 times 3, etc. This is a handy thing. Permutations are not in IB. So I'm going to just write on the side here. These are not in IB math. They are in the data management course, grade 12, but we don't really do them. So you just wanted to give you some background information. Now this idea of 3 times 2 times 1 or 10 times 9 times 8 times 7 times 6, instead of writing it all out, we have this quick kind of mathematical way of writing it. 3 times 2 times 1 we can write as 3 factorial, 3 with an exclamation mark. This is not 3, this is 3 factorial is how you would pronounce it. So if you see this 7 factorial, well, that means 7 times 6 times 5 times 4 times 3 times 2 times 1. As you can imagine, factorials are massive numbers because when you multiply these numbers together, they get really large. Can you imagine typing 100 factorial? It would be a really big number. N factorial. Well, this is the number. This is a theoretical number. So what we do is we multiply, that number, so 7, times the number before it. So n, we'd multiply it by the number before it, n minus 1. And then times 5, that's the number before that, so n minus 2. Times n minus 3, and we keep going forever. So that's kind of the general case, theoretical. So it's always the last number times the number before it, 6 times the number before it, 5, 4, and then et cetera, et cetera, et cetera. Okay, so let's look at things like this. We can do some really neat factorial math here, because you have 7 times 6 times 5 times 4 times 3 times 2 times 1. And this is 6 times 5 times 4 times 3 times 2 times 1. These are all being multiplied, so actually these cancel out with these. So you end up with just 7. It's kind of neat how that works. Similarly, here you have 7 times 6 factorial. 7 times 6 times 5 times 4 times 3 times 2 times 1. Well, that's just 7 factorial. 7. The thing that is going to be most difficult to understand, and this is going to kind of come up later, so it's good to introduce it now. This can be simplified because I know the n factorial is n times n minus 1 times n minus 2 times n minus 3 times dot 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 dot. And this in the denominator is n minus 2. Okay. Now I have to multiply it by 1 less than that. So that would be n minus 3 times 1 less than that, and n minus 4, dot, 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 dot. Now look at the similarities. You have n minus 2 times n minus 3 times dot, 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 dot. That's the same as here. So these cancel out. So I'm left with n times n minus 1, which is n squared minus n. So you can see how by expanding a little bit, you can cancel out the thing that's common. Remember, n factorial goes on forever. Right? It gets smaller, smaller, smaller. We don't know what n is, so it's almost a very theoretical thing to talk about. Okay, so let's keep going. So that was our, we talked about permutations, we talked about factorials, which are definitely in the course. Now we want to talk about combinations. So this is the other side of combinatorics. Before we were talking about placing 3 students in a 100-meter run, order mattered. In this question for combination, we want to change the question. How many different teams of 2 can I create from 3 students A, B, and C? Okay, so different teams of 2. So I could have a team AB. I could have A instead partner with C, and I could have B partner with C. And that's it. Those are my 3 combinations. Because look, I could have B partner with A. Oh, but that's the same group as this. So the order doesn't matter here. Unlike the first example, order doesn't matter. So how do we get 3? Again, what do we do if we have like a larger groups to deal with? It would take a long time to draw all the possibilities. But this idea of choosing 2 items from a group of 3, we call a combination. And we deal with it a lot in math. We write 3 choose 2, or 3 choose 2, or 3 2. Or actually, C with a 3 2. So all of these are 3 ways of writing 3 choose 2, the combination 3 choose 2. You have 3 items and you want to put them in groups of 2. Whereas before we learned a shortcut, the shortcut here for any combination looks like this. N choose R, so we're going to use that form just because that's the one that's more and more current, is n factorial over r factorial over n minus r factorial. Oops, sorry. Factorial should be outside, sorry. Where n is the number of items and r is the number of selected items. Now that's my formula. So watch this. We can do a question. A restaurant has 7 desserts. How many ways can 2 people buy 2 different desserts? So how many ways can I group these 7 desserts into groups of 2? You know, I can get a pie and a cake, or a pie and ice cream, and there's all these different, how many different possibilities are there? Well, we're going to use, because it's a combination, we're going to use the n choose r formula. So it's 7 possibilities, and we're choosing 2. So that's going to be 7 factorial over 2 factorial, 7 minus 2 factorial. Now, I know this looks intimidating. Let's just do what the easy math is, which is 7 factorial over 2 factorial over 5 factorial. Oof. Okay, well, I can write this out. 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. 2 factorial is 2 times 1. And 5 factorial is 5 times 4 times 3 times 2 times 1. Okay, now these things cancel out. So I'm left with 7 times 6, which is 42, over 2, which is 21 possibilities, 21 combinations. Okay, let's continue to the back. And so that's neat. There we go, we have our final answer. Okay, let's go over here. Actually, before we go to that, look at this number. We actually could figure out 21 without doing all this work. I mean, it's good for us to understand this work, but both your GDC and your regular calculator can do this. So, for example, 7 choose 2. You can go to your regular calculator. First of all, the factorial button is also on your calculator. 3 factorial, I would just type 3. And where's my factorial? Right there, it's an X exclamation mark. You have to use the second function, shift second. So there it is. That's how I do factorials. So, you know, you've learned a new calculator button. To find 7 choose 2, so combination, I'm going to type 7. And then my choose is down here, NCR. It's the same format. Shift divide, so I get choose 2. And there it gives me the answer of 21. There's instructions how to do this on your GDC as well. The easiest thing you can do is type NCR into calculator and then bracket 52 comma 5, or you could go menu probability combinations and type in these values. So that's one way of solving this mathematically. But it's good for us to understand how this formula works a little bit. There's some tricky homework questions. There's also this tricky question here, this tougher example. Let's say you want to solve for n. So in this case, I want to group some amount into groups of 2 and have 15 groups. So you imagine if I have 3 desserts and grouping them into groups of 2, well, that doesn't give me 15. This could be 4. So then I'd have 4 groups of 2. That wouldn't give me 15. So this is some number, right? I have to figure out what it is. Fortunately, I have a formula, right? I have n choose r is equal to n over r n minus r factorial. So over here, I would have n factorial over r, well, r is 2 factorial, n minus r, oops, sorry, n minus 2 factorial is equal to 15. Okay, well, now we have to do a little bit of math here. We can do this thing, well, actually, let me bring the 2 over the other side. So I have n factorial over n minus 2 factorial equals 15 times 2 factorial. So those are just numbers. But this looks a lot like that tough example I showed you on the other page. This is n times n minus 1 times n minus 2, etc., 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 n minus 2 factorial. Then this is n minus 2 factorial. And this is 15 times 2 times 1. Now, the n minus 2 factorial, those cancel out. So I'm left with n times n minus 1 is equal to 30. So this is n squared minus n is equal to 30. So that's n squared minus n minus 30 equals 0. Neat. This is a quadratic equation, and actually I can solve quadratic equations. I learned how to do this. I just have to factor this. So this is going to be n minus 6, I believe, n plus 5 equals 0. So then I get n equals 6 or n equals negative 5. Now, n cannot be negative, right? N can't have negative deserts and to put them into groups of 2. So this is extraneous. So therefore, n equals 6. So if you take 6 and put them into groups of 2, you get 15. Again, I could verify this with my calculator. 6 choose 2 is equal to 15. So hopefully that helped shed some light on how to do combinations. It's pretty neat, pretty straightforward, except for some of these questions where you're dealing with n. Please take a look at the homework there. It's at the bottom of the page. Good luck, and until next time.